Hello everyone, welcome to the third lesson of the Prepathon, which is on avoiding unforced assumptions. Now, this is a mistake which a lot of students make while solving questions, and what we usually categorize as silly mistakes. You read a question stem and you start making certain assumptions which lead you to make certain inferences which are not correct. Okay, and that obviously leads to you making silly mistakes. Now, to help you understand this, what I'm going to do is I'm going to take certain examples to help you understand what are some of the incorrect assumptions which are made by students. Okay, and let me start off with the first and the most common mistake made by students, which is assuming variables as integers. So, to help you understand what I mean by that, I'm going to take a very simple example here. Now, look at this question. I'm not going to solve it, but I'm just going to tell you what do students assume, because of which they start making a mistake while solving the question. You can pause the video and read the question if you want to. Now, in this question, it is given that x is odd. That means it's an odd number. And a relation is given between x and n, that x is equal to 4 plus 3 times n. And we need to find out what is if n plus y is even or not. Okay, now what students usually do is they look at this expression and they start thinking about the even odd nature of n. Okay, and this is how they usually proceed and solve the question. So 4 is an even number, so they write 4 as even. 3 is odd, and we also know that x is odd, so we replace x with odd. And from here, usually we try and find out what is n, right? And this is what you usually do. You write odd is equal to, so you look at this expression, you see the overall expression is odd. If this is even, then even times odd times n, which from this you should be able to infer that n basically needs to be odd. Okay. And since you see infer that n is odd during a pre-analysis, while finding out the answer, what you do is that you look at statement 1, you see y is odd, you know n is odd, and then you say odd plus odd is even. Okay. Similarly, you look at the second statement, you see n times y is odd. Okay, so if n is odd, you assume y also has to be odd, and then you say even this statement is sufficient, right? If you want, you can try and solve it the way I've discussed now. And ultimately, if you go with this approach, you end up marking the answer as D, right? Now, let me tell you that this is incorrect. The assumption here that you made while solving this question is that n is an integer. Now, tell me, is it anywhere written? Do we know that n is an integer? No, right? Now, nowhere is it mentioned that n is an integer. We just know that x is an odd number. So x is an integer is something that we definitely know. Okay. And even while reading the question stem, nowhere is it mentioned that y is an integer. Only when we look at this statement do we find out that y is an odd number. So y is an integer. Okay. But let's talk about n. We assumed n is an integer, which is incorrect. And let me show you why. Now, if x is equal to 4 plus 3 times n and x is odd, isn't there a possibility, for example, that n is, say, 1 by 3? Now, if you take n as 1 by 3, 3 times 1 by 3 gives you 1, and 4 plus 1 is 5. And even that is odd, right? So it is quite possible that if n turns out to be 1 by 3, and in that case, n is neither even nor is it odd. So your assumption while solving the question that n is an integer is incorrect. Ideally, after reading this question stem, while solving the question, you should solve with an open mind and think in this way that, hey, x could be a real number. Let me try and see if there's any real number that fits here, like a fraction, and let me see if an integer fits in. And from there, you should start solving the question and approaching it in the right manner. If you don't do that, if you simply assume it's an integer, you'll end up marking D, which is incorrect. Okay, so this is the first and the most common assumption that I've seen people make, that is assuming variables as integer. Another common and frequent assumption that I've seen that people end up making is assuming integers or squares as positive. So sometimes you may be given the variable is an integer. It might be written in the question stem. So I've just taken a sample question stem. I'm not asking you to find anything as such. But if you look at this question stem, it says that if x is an integer, is x square plus y positive? Okay. Now, here's the first incorrect assumption that people end up making. They see if x is an integer, what they ultimately end up doing is that they think that, hey, x is an integer, so they start thinking if for values like, say, 1, 2, 3, 4. So unconsciously they are thinking about only positive values, which is incorrect. If it's an integer, it's possible that x can be negative also. It can be a negative integer like -1, -2, -3, and so on and so forth. Okay. Another incorrect assumption that they end up making is that when they look at x square, a even powered number, they ultimately end up assuming that it's always positive. They look at x square, they say, hey, it's positive. And they're partially correct. If x, see, x is a variable, it's an integer. And if you have x square, then you also need to ask yourself a question that if it's an integer, can't x be 0? Okay, it's quite possible, right, that 0 is also, it's quite possible that it can take positive values, it can take negative values, and it can take 0 also. If it is 0, then 0 square is 0, and it is and 0 is not positive. 0 is a non-negative number. Okay, so there's a number of cases where you end up forgetting about 0, you don't consider 0, you start from solving from 1, 2, 3, 4, and you may miss out a case and end up marking the incorrect answer. Okay, so make sure that you don't make this mistake. If you see that it's given x is an integer, always make this inference that, hey, if it's an integer, then x can be negative, it can be 0, and it can be positive. It can take any values, +1, 2, 3, 4, -1, 2, 3, 4, or 0. Okay, so these are the assumptions that these two assumptions are something that you need to stop making. Another frequently unforced assumption that I've seen is while solving questions on geometry. Okay, whenever you look at a question is given to you, and I'm again going to help you explain with the help of an example, whenever you look at a diagram, you end up assuming a few things, okay, which may or may not be correct. So for example, it's given here that PQ and QR are 6, and I need to find out the area of the triangle, okay, and say no other information is given to you. So what people usually do is they look at this diagram and they make one assumption, and that assumption is, hey, it looks like 90 degree, so let me assume it as 90 degree. Okay, and the moment that they make this assumption, they find out the area as half base times height, 6 times 6, and they say that the area is 18. Now, after looking at the diagram, you should ask yourself first before making an assumption that, hey, is angle PQR 90 degrees? Okay, now if you just say that, hey, it looks like 90 degrees, so let me take it, you're wrong. You should not do that. We should not just go by how the diagram looks. Okay, we should be 100% sure, and we should use the information given the question to make the inference that it is 90. If nothing is given, we'll simply say, hey, we don't know anything, so we'll not assume anything at all. Okay, and that is why the area that we have found by assuming that it as 90 degree is incorrect. So the major takeaway once again here is that do not assume anything, please, by just looking at the diagram. If you do that, you'll end up making a mistake. Another and the last assumption that I'm going to talk about is quadratic equation. There are many more other assumptions that people make, but these are some of the frequently seen mistakes or assumptions that I've seen. Now, whenever you look at a quadratic equation, you usually end up thinking that it's a quadratic equation, so it will have two distinct solutions. Okay, and to help you understand this, I've taken this example here. See, if the question says what is the value of x by y, and you're given a quadratic equation. Okay, now what people usually do is they look at this quadratic equation and they make that assumption that, hey, it's a quadratic equation, two solutions possible, and if the answer option has cannot be determined, you mark that and move on. And I've seen a lot of people do that. But please keep in mind, GMAT knows that you have this habit of making these kind of assumptions. So it's very important for you to be aware that you're thinking like this and try and stop yourself from doing it. Okay, it's always best to solve and then come to the conclusion, yes, there are two different solutions, so the answer cannot be determined. Now in this case, if you look at this equation and you try and simplify it, you'll notice that this 4xy can be written as 2x whole square. This 12xy can be broken as 2 times 2x times 3y, and you have 3y whole square. And this is nothing but a minus b whole square. This, if you're not aware of this formula, maybe in that case you need to go through the standard identities that are used in the GMAT. But those who are able to recognize this, they will be able to understand that, hey, there's only one possible value of x by y, and that is 3 by 2. Okay, even if you try to middle term factor, you'll end up with the same result. So it's not it's still okay if you're not able to recognize the standard identity. You should know how to solve a quadratic equation, and you should solve it, find the answer, and then check if there are two different solutions, and then mark only cannot be determined. Otherwise, don't. Else you'll fall for a trap like this because you made an assumption in the beginning only. Okay. So these are the most frequently made unforced assumptions by students. I'm going to take one full question, and I'm going to show you how we should solve question with an open mind, and we should ask questions about the variables, questions about the diagrams, and then only come up with the inference. So as usual, let's take a question. I'm going to show you once again, and this is I'm going to discuss this in detail in both the ways, how a student solves it. Very elaborately, I'll show you where you make mistakes, and then I'm going to show you what's the right way to solve the question. Okay, so if you want to pause the video and read the question or even try it, please do so. Now, in this question, it's given that ABC is an isosceles triangle and AD is perpendicular to BC. And we need to find out what is the area of the triangle ABC. Okay. Now, obviously what you need to do is, after looking at this question, ask yourself a few questions. But assuming that a student is solving who makes these kind of mistakes, what he's going to do is, once he reads that ABC is an isosceles triangle and he looks at the given diagram, there's a high chance that he will make the first assumption without even realizing it. And the assumption that he'll make is that AB is equal to AC. That is, these two lengths are equal. That's the first assumption that he'll end up making. Okay. After that, once he sees that AD is perpendicular to BC and he has made the first assumption, he'll end up making another assumption. He'll say that, hey, it's an isosceles triangle, these two sides are equal, I'm dropping a perpendicular from here, so obviously these two lengths must be equal. So that's the second assumption you'll make and mark these as equal. And once you make this assumption, what you're going to do is, you may end up writing this, that BC, the whole full length here, is nothing but twice of CD, or even you can say twice of BD, whatever you want to say. But the idea is it is twice of the individual length that's given here. Okay, so these are the two unforced assumptions you are going to end up making by just looking at the diagram at the information. Okay, without asking yourself relevant questions. And the moment you do so, when you're trying to find out the area, what are you going to do? You're going to write half base, which is BC, times height, which is AD. Now you know BC is twice of CD, right? This is 2 times CD. So you'll replace BC with 2 times CD, cancel half and 2 out here, and end up saying that area is CD times AD. And this is an incorrect inference. I'll talk about why is it incorrect, but it's incorrect. And you'll understand in a moment why is that the case. So assume that you make this inference. Okay, you took two assumptions, and on the basis of that you made this inference. Okay. Now what are you going to do? You're going to analyze the statements, right? Now let's look at the first statement. You'll say the first statement is AC is 5, but you know that you need CD and AD. So you'll say even if we know AC is 5, we don't know CD or AD. So this statement is not sufficient, right? Similarly, you'll move on to the second statement. Okay, in the second statement, you'll say that it's given that AD is 4, so the height is given 4. If the height is given, you know AD, but you still don't know CD, right? So even if you know AD, you don't know CD, you won't be able to find out the area. So even this statement is not sufficient, and you'll cancel out option B also. So these three cannot be your answer. So you're left with C or E. But with this inference in mind, with this incorrect inference in mind, you're still solving the question. Now, when you start analyzing, combining both these statements, when you combine both these statements, you know that AC is 5, AD is 4, and you'll put that in the diagram. Then what you're going to do is, you're going to apply Pythagoras theorem and find out CD. So you'll say CD square is AC square minus AD square, and after solving, you'll get CD as 3. So once you get CD, you'll be able to find out your area, and once you find out your area, you'll end up seeing that the answer is C, which is incorrect. Now, I know I told you this is an incorrect inference, and I'll tell you why. So let me ask you a question. How do you know that these two lengths, that is AB and EC, they are equal? That was our first assumption, right? Is it anywhere given in the question stem that these two lengths are equal? It's not mentioned, right? Nowhere is it given that these two lengths are equal. So assuming that these two lengths are equal is incorrect. Ideally, when you see in the question stem mentioned that ABC is an isosceles triangle, or there's an isosceles triangle basically, don't just blindly assume that only these two lengths can be equal. It's quite possible that say AC and BC are equal. It's quite possible that AB and BC are equal, right? And since we don't know and make this assumption, we end up making a mistake, because based on this assumption, if AB is equal to BC, only in this case when AB and AC are equal, can you infer that BC is equal to BD is equal to CD. The second assumption. The second assumption is totally based on the first assumption, and we don't know whether the first assumption is true or not. Okay, and since we don't know that, making such assumptions beforehand is incorrect. Okay, because for example, if AB turns out to be equal to BC, then we can never say that CD and DB are equal. We cannot, because we don't know whether the perpendicular is dividing it equally or not. Okay, so making such assumptions will lead you to mark your answer as C, which is incorrect. Now let's talk about the right way to solve the question. Well, when you read the question that ABC is an isosceles triangle, you should ask yourself, which sides are equal? Do you know that? Well, you don't. So don't make any assumption. Simply assume that any two sides can be equal. Either write it down or just simply keep in mind that any two sides are equal. Okay. Then ask yourself, is BD and CD equal? Is it anywhere given in the question that they are equal? No, it's not given, right? So don't make this assumption that they are equal. They will only be equal when you know that AB is equal to AC. Only in that case you can say that BD and CD are equal. So that's the right inference. And also you should infer that, hey, I don't know which two sides are equal, so I'll try and find out which sides are equal. And if AB, AC are equal, then only I'll say that BD and CD are equal. Okay, so that's the right approach. Not assuming anything, asking myself the right question and solving it. Okay, now once I analyze the statement, it's very easy for me to analyze. I know what I'm looking for. I'm trying to find out which two sides are equal, and on the basis of that, I'll take a call what I need to do. So I look at AC is 5. I know AC is 5, but I don't know about CD or AD. I don't know which two sides are equal. So obviously statement 1 is not sufficient. So your answer cannot be A or D. Then I look at the second statement. AD is 4. I know if AD is 4, but we don't know what is CD. We still don't know what is CD, and we still don't know which two sides are equal. So once again, we'll say statement 2 is not sufficient, so answer won't be B. And I'm sure by now you must have understood what will be the correct answer. So even if we combine, all we can do is apply Pythagoras theorem, find CD is 3. But to find out our answer, we need the full base, right? Base is BC. If we know CD is 3, and unless until we don't know BD and CD are equal, we cannot find out the area. And we cannot find it because we still don't know which two sides are equal. And that is why we'll say that we don't know which two sides are equal, whether BD, CD are equal, and hence we cannot find out the area ABC. And therefore, the correct answer in this case will be option E. So this is how GMAT is going to trap you if you make such incorrect assumptions, assuming which two sides are equal, assuming these two are equal, and end up marking the wrong answer. So it's very important to have a strong conceptual knowledge also, guys. Think in this way, that you should know that in an isosceles triangle, if you're dropping a perpendicular from between two equal sides, only then these two lengths BD and CD are equal. For example, if AC is 5 and say if AB is say 6, and if I drop a perpendicular from here, these two won't be equal. Okay, so having a strong conceptual knowledge also plays a big role in helping you avoid making such assumptions. So make sure that you solidify your conceptual knowledge also. So the final takeaway is, do not assume anything about the nature of any variable. Okay, if nothing is mentioned, just assume that it's a real number. That's all. It's a real number, and then solve the question with an open mind. Okay. In case of diagrams, do not just assume anything by looking at the diagram. Hey, it looks like 90 degree. Hey, it looks like 60 degree. Don't do that. Okay. See what information is given, and based on those information, make some inferences and then solve the question. Okay. Then you'll never ever make a mistake. So that's it from my side. I hope you enjoyed the lesson, and hopefully you will start avoiding these mistakes and start avoiding making such assumptions. Now, once again, we'll be giving you two questions. Try and solve them, keeping all the learnings in mind.